Especially for ultra-fast charging, a battery management system is extremely important to keep the battery cell in the optimal temperature range. Furthermore, you need to have a low temperature spread within the whole battery pack to prevent accelerated cell aging. On the other hand, you need a really small, light and efficient battery management system to keep the battery density as high as possible and, of course, to reduce the weight. By modeling the battery thermal management system, you have the opportunity to compare different ideas against each other. So we had different approaches like water jacket or immersion cooling, and then we compared, for example, the absolute temperature of the cell, the average cell temperature, but also the temperature spread, the weight and the number of components. And we ended up with an L-shaped cooling fin design, which is attached directly to the cell with thermal pads. Combined with a lower cooling plate and the two cooling rails on top of the bus bars, we can achieve our system requirements. With 3D simulation you can cover the reality quite good, but this needs a lot of computing time. You can reduce the model order to increase the efficiency of simulating it. This combination we used to calibrate our control strategy. So we simulated different use cases and tuned the system. So we were looking for improvements on our thermal management system. We took into account the thermal conductivity of the thermal pad of the cell itself and the aluminum cooling fin. Furthermore, we analyzed the influence of the cooling channel design on the temperature and the temperature spread. It came out that the thermal pad had no significant influence on the average cell temperature, but so did the cooling fin and the optimized cooling channel design. It can be shown that the average cell temperature can be reduced by 1 degree C while remaining the temperature spread within the battery pack. The first finding is that you need a two-sided cooling system. One on the bottom and one on the top to cool the bus bars to keep the temperature spread as low as possible to reduce the cell aging. Another finding is that you can improve the thermal management system by tailoring each part to its position in the cooling system. Another finding is that you have many other options to improve the battery management system. For example, by tailoring each part to its position in the battery pack to reduce the average cell temperature and reduce the temperature spread within the pack. The next steps are to evaluate our battery management system design and our control strategy on the test bench conditions. With the results we can adjust our control strategy on the one hand, but also can see the cell aging on the other hand. This sophisticated BTMS cannot increase the range of an EV, but it can reduce the charging time you need and will increase the lifetime of the battery for a higher acceptance of electric vehicles in the society.